good.
Live streaming is on.
Hello, everyone, and welcome to this week's edition of the Jitsi Community Call. So, as promised, we're going to be talking about the way that we do infrastructure on Meet Jitsi. We have decided that because there's a lot to say, we are going to split this in two episodes. We're going to do the more generic part now. We're going to see what the questions are, and we're going to address that in the next version, next week. So this first episode is going to be hosted by Saul, and we'll start in a minute. Just a couple of quick updates first. So, Zoli, how's the lobby room going?
It goes fine. I'm doing the final changes that we discussed on Friday. Was it on Friday, I think? Now we are not going to have a notification for the knocking people, but like a list. I've actually sent you a screenshot a few minutes ago. I think that will be done today, and I'm not sure how Damien is with this turn on and off bug, but I think other than that, we should be good to launch soon. Yeah, basically, that's the update.
All right. Thank you very much. This is hopefully something that's going to be useful to many people. We were also talking about things such as trying to provide people with a way to be exclusive moderators and ways to host large meetings in a more controlled fashion. We're still thinking about that. It's not something that's currently being developed, but hopefully we're going to have more answers there soon. All right. Christo, you wanted to share something too?
Yes. So there were a number of reports that basically Jitsi Meet is, let's say, not working when the browser doesn't support the local storage for some reason, like either the browser just don't support it or the user have disabled it from the party cookies, and I don't remember actually what was the real name of the option. So that should be fixed now, and basically we're handling this gracefully, and everything works just without local storage. Yeah, so I guess that's all from me.
Thank you, Christo. We also now, something we've had for a while, but I don't think we ever mentioned publicly, was the ability to control your video quality now also impacts your outgoing streams. So if you choose your low definition or standard definition, that would also impact the resolution that you're sending in, which will in itself have a huge impact on CPU. So if CPU usage is something that concerns you in general, make sure you do use that option. And the new thing is that since recently, it's now also possible to do that from the iframe API. Jay, would you like to give a couple words about how people can do that?
Yeah, sure. So yeah, last week we introduced this change, and with the iframe, there is this set video quality command. You would have to specify the height of the resolution that you want. And yeah, it's a simple API.
And you also said a couple of questions there. Would any height work? Should people limit themselves to the classics or?
Yeah, I mean, so right now, so in the simulcast case, we've set the max to 720p. Like if the user starts the camera at 720p, then the max obviously would be 720p. All the layers up to whatever is specified using set video quality will be turned on. But yeah, other than that, there are no restrictions.
All right, thank you. Also, there were some requests for being able to control high frame rate desktop streaming, desktop sharing, which Jaya, you added a few things there as well. Would you like to talk a bit about that?
Yes, so we had this bug where when we were doing either P2P or when we were turning on screen share and disable simulcast for screen share, we were setting the Google Conference flag. So that would actually prevent Chrome from sending the high 30 FPS screen share. So that should get fixed now. So with P2P and even in the JVB case, we should be able to actually send full 30 frames per second when we specify that in the options, the screen share options, the min and the max.
Okay, thank you, Jaya. I think that will conclude this week's round of updates, and we can move to the presentation of the infrastructure that Sue was going to talk about. Sue, was there anything else you wanted to add first?
Yeah, I wanted to add something before we switch to that. We have received feedback from the community that our GitHub repo, the main one for Jitsi Meet, is kind of a dumpster fire, and they are not wrong. It's a little bit messy right now. And some people have volunteered to help, and we are going to trial that. So after this call, I'll open a new issue, and those who want to help out can sort of sign up there by leaving a comment. And we're going to try this by giving those people the triage role in the repo. That means that they will be able to close duplicate issues, label them. We now have some better labels, and overall help with the maintenance of the repository. So it's more accessible for people to report problems and for them to reach us better instead of being buried under $200 issues. If this is something you like to help with, then yeah, stay on the lookout.
Thank you, Sue. Actually, speaking of issues, I also like to give another update there. We have had a number of updates, a number of reports from people out there who were able to have one-to-one party calls on Meet Jitsi. Specifically, this is about Meet Jitsi. And as soon as that conference were to switch to a multi-party call, it would either take a very long time for audio and video to start working, or they won't start at all. We have been chasing this relentlessly over the past few days. It was a very complicated problem. We think it is largely solved at this point, although there are one or two edge cases that we think might still be lingering out there. We're looking at it closely, but the overwhelming majority of people who reported this shouldn't be seeing it anymore. There was another question about whether or not that could have been impacting individual installations. It's not impossible, although people who experience that in individual installations are more likely to just have their bridge down or something like that. So I would say for an individual installation, that wouldn't be the first place that I would personally go to. All right. So with that, so take it away.
All right. Let me share my screen over here. And so I'm going to present on the architecture that runs Jitsi. This part, most of this presentation I gave at the Matrix event earlier this last month. But I think this community may have different types of questions. So that's why we're doing it again in an abridged fashion. So let's start with how Jitsi runs. We have this concept of a shard, which is a server that handles signaling and a number of servers that handle media. When we say server here, we're currently running these on AWS. So each of these orange boxes right there would be one virtual machine. This presentation was written, we were running 5x largest, actually 4 cores, 8 gigs of RAM. I believe we have upgraded to 16 cores, 32 gigs of RAM, if I'm right, Emil, or anyone else?
Yeah, I think 64 gigs of RAM, actually, I think.
Oh,
and 8
okay.
cores.
8 cores, all right. So the core count is the most important factor here. And the signaling nodes run Nginx, which handle the WebSocket connections or HTTP connections. for signaling that are then passed through to Prosody, which is your XMPP server of choice. And then we have GCOFO, which is the conference focus, or basically the folk at the door that lets users in or out and communicates with the bridges to allocate channels and connect people together into a single conference. So this would be one shard, or what we call one shard. But then we have a number of shards, and the traffic is sent to those shards load balanced by HA proxy. And then that traffic is sent into the HA proxies by the Amazon ALB. And this would be the view of one region, let's say. So how does all of these sort of, how does traffic end up in the right place? Well, we use Route 53 and the global accelerator together. And that means that when your browser does the DNS lookup for me.jit.si, you will end up in the closest region to your to where you are, and you will be directed to the ALB that's right there. Now, there, going back a bit, you'll see that we have two HA proxies in the picture. We can have more than those, but for the purposes of illustration, we have two of them right here. That part of the load balancing is done brainlessly, so it will go to either of the HA proxies. An important part here, as you can see, all the shards are connected to the HA proxies. HA proxies know about all the shards live at any point in time by having some synchronized stick tables. Because what happens when a conference is created is that all the other participants need to be routed to that specific shard so that they are connected to the same parts of the signaling. And that is how an HA proxy, the load can end up in an HA proxy, and then it will go to any shard, even if it's not in its own region. That is how we connect all the shards to HA proxies. And then going forwards a little bit, we will end up in those HA proxies through the ALB that is chosen by Route 53 or the global accelerator. We're going to talk about the global accelerator a little bit further, but basically what it allows us to do is to decide how much of the load we want to send to one region or not. So for example, if a region is specifically loaded, you could say we'll only send in 70% of the load here, and then the rest can go and even itself out to the other closest regions. Now, how many of those regions we have? As you can see there, these were the regions that we had before the start of the crisis. So we had two in the US, South America, two in Europe, Southeast Asia, and Australia. And then the floods began with the current situation. So we got ready by over provisioning all of our infrastructure, adding more shards and everything. But at one point, every single component was on fire. So the media nodes, the JVBs were on fire, the signaling nodes were on fire, the HA proxies were on fire, everything was on fire. And in the very early days, everything failed. Everything that could possibly fail failed at one point in time. So let's take a look at what went wrong in all of this. Well, of course, at this point we were in panic mode, so all hands on deck, trying to find whatever problem we could and patch it. This meant SSH into production servers. Don't try this at home, but hey, sometimes you just have to. So one of the first things we ran into was that our file descriptor limits were too small. So we were running out of file descriptors in many of our processes, Nginx, Prosody. So we can bump them, but how do you do that in production without restarting the service and then running into potentially more problem because of a thunder and hurt problem? Well, it turns out that PR limit allows you to change this for a running process, and then boom, suddenly things begin to work a little bit better. Another problem we ran into was ephemeral port exhaustion. So basically, when you have something that, when you have a load balancer, it probably always sends traffic from the same IP address and port. And you will always receive it on the same IP address and port. And between these quad, you can only have 65,536 connections because one ephemeral port is allocated for each. And when you go beyond this limit, you're basically out of luck and you get socket errors. So, well, an easy way to get out of this is to add more elements so that you can have more combinations. So, for example, add another IP address where traffic can be sent to or from another port. And even if the data ends up on the same server, you will still add more of these quad combinations, and you can cope with the load better. Next, we discovered that our inter-server traffic was actually killing us as well. Not only the one we received from the outside, but our servers that talk to each other were too chatty, and this was killing us. So at this point, we made each JVB connect only to its own shard. We used to have them connect to every single shard so that we could then have Octo enabled. We can get into Octo later. But this created too much XMPP traffic for statistics and load publishing, so we had to turn that off. So takeaway here would be that it's not only the external traffic that can kill you, but also your own internal traffic. We even had some prosody modules that were publishing some events to a remote service. And of course, this escalated very quickly because we get so many more events that then the load was basically unbearable. So at this point, we had lots of negative feedback in every possible channel. So we started reacting to it. And a good way to react to it is to just overdo it. So we provisioned thousands of servers and to be able to deal with this load. We even launched a new region. We didn't have Paris, but we added it at that point. And this helped us deal with the load in Europe, which was and still is the biggest point of load. EU Central was our hot point. And this way we could deflect some of the traffic to, for instance, Paris, so EU West, or to London, so that EU Central wasn't that heated. An interesting thing to point out at this point is that this design for this infrastructure was devised in 2015. And at that point, all of this was basically overdoing it. It's not really needed, but let's do it anyway. But fast forward to right now, hadn't we had this thing in place, it wouldn't have been possible to scale so quickly with the amount of people to join the service without having to re-architect everything or something. So we were able to provision more servers, add new regions, spread out the load, and deal with it pretty gracefully after the first week of chaos, I might add. But this is a testament to the good work of our DevOps guys. So Aaron, shout out. Now, what helped us here once we had the new region there is the global accelerator. This was instrumental to balance the load. Now that we had more regions and the hot one was in Europe, as I mentioned earlier, you can tune it and say, well, only send 70-80% of the traffic to EU Central, the rest will be spread out. So it will go to, for instance, EU West, and then you will have two regions that are handling the load more evenly. And this was caused mainly because Italy was the biggest user that we were having, and they were all hitting EU Central. Now let's look at some numbers so far. Now these changed pretty much daily, weekly, very quickly, but this is a snapshot of it. So we are now handling 60 times more conferences on a daily basis than we were doing before. Our participants, our concurrent participant count has gone up 300 times on the very first few days of this whole shebang. And overall, when it comes to relay and traffic, pure network traffic, we're almost 200 times more, probably up to 200 right now since I took this piece of data. And importantly, instead of managing tens of servers, which is manageable, you can SSH into places, you can take logs and do stuff. Well, we now have thousands of servers, which makes, well, pretty much everything a bit more complicated. Thankfully, we have good automation in place to help us deal with this. But this is a glimpse of how things changed in a period of, well, began with days, but then weeks. We went from just having a handful of servers then thousands. Now, what are we doing going forward? Because, well, this operation needs some optimizing. We're planning on optimizing our use of resources. And one way is to optimize our transit cost, because that is very significant. So moving bridges away from AWS to a different cloud. Right now, we're moving to the Oracle cloud. That would allow us to actually scale a lot more while keeping the cost at bay, just because of the sheer cost that it's the network transit on the AWS infrastructure. And last, we're also in the process of moving away from HA proxy stick tables. As I mentioned before, this is what allow us to keep a list, if you will, of meetings and on what chart they're happening. And at the current load, split brain, so basically two users that enter the same meeting being in separate and disconnected meetings, that's a split brain, are right now pretty much unavoidable. It's a small percentage, but it's there, and we'd like it to be, well, zero. So we're moving away from those. Probably Aaron can give next week a better description of what we're doing next in this regard. I know that we're moving away from it. But if you're thinking about deploying some infrastructure with this architecture, this doesn't mean that this solution is bad. It means that at the current scale, there might be better ones. And that pretty much concludes what I wanted to go over when it comes to architecture of Jitsi and what we did with it.
Thank you, Saul. We're going to go to meet Jitsi shortly, but let's have a look at a few of the questions that have been coming in. So there's been a question, I'm trying to rephrase this, but there's been a question about the Dockerization of things and how it fits into all of that. Would you like to talk a little bit about this?
Well, right now, we use AMIs that we built for a specific version, and we deploy those virtual machines. We do have the Docker setup, which we are not deploying with right now. I think that Dockerization can help do faster rolling updates, because replacing a running container should be faster than replacing an entire VM and building images, because you basically already did when you built the images for Docker. We have talked about starting to look into go in this direction ourselves. It isn't clear, at least to me, like what direction we would follow, specifically if it would still involve having some form of VMs or go full-on containers like Kubernetes style. But Kubernetes also has its own challenges it's very oriented to HTTP-like services or TCP port-based things. And when you add into the mix the video bridge, which is a UDP-based application, really. And you cannot blindly load balance the UDP packets because they need to end up in the right JVB so that you get the packets in the right conference. So we either need to develop some UDP demultiplexing entity or find a different way around it. There's still some work to be done to see how they can help us at scale.
Thank you very much. I actually think this is we're going to cut it here because I think this is a great presentation, and I'd like to keep it short so that people can use it outside of the context of the call. There are more questions, but I think we're going to resort to meet Jitsi the call to go and answer them. And at this point, I'm going to cut the conversation here. Thank you very much, Sue and everyone, and meet you shortly in Meet Jitsi / the call.